My name is Ryan Church, and I'm the founder and CEO of Biome Renewables. Biome is a biologically inspired engineering and design startup based here in Toronto. We're focused on the PowerCone technology, primarily in wind and tidal energy. The PowerCone technology is our flagship technology that we're bringing to market. It's an aerodynamic and hydrodynamic retrofit technology for wind and tidal turbines. When we first started to think about how we wanted to prototype our tidal PowerCone technology, we reached out to the Nova Scotia Community College, which had a Renishaw additive manufacturing 3D metal printer. And in working with them, we realized very quickly that we could make a tidal turbine very cost effectively and very quickly and get it into the ocean.
My name is Neil Lomanen, and I'm the project coordinator for applied research at the Nova Scotia Community College. NSCC Applied Research works with industry to find solutions to their real-world challenges. When companies need products manufactured, the team relies on my expertise and the suite of manufacturing technologies found in the Design Center.
When Neil first approached us for technical support, we knew right away this would be a great project to work with Biome Renewables. NSCC was the first college in Canada to have a metal printer, and it was great to see them producing parts like this, even on an older machine.
Biome Renewables approached us to build 2 versions of an underwater turbine prototype. Their goal is to apply their innovative wind technology to tidal. We used the Renishaw 3D metal printer to meet a tight timeline to get the prototypes built in time to be shipped to Ireland for testing.
When the project grew from not just 1 turbine but 2 turbines, in order to meet the project timeline, we decided to split the work between us, with NSCC producing some of the components and Renishaw's Solution Center producing some of the components here. And this let Neil focus on final machining and assembly of the parts ready for testing in Ireland.
3D printing, for us, it helps us get prototypes in the water so we can get data faster. The PowerCone geometry is also a very unique and complex curved geometry, which actually lends itself very well to 3D printing. When we look at the financial implication of using 3D metal printing, we realized that there was about an 80% cost savings alone in going this route, just through time, materials, and getting it to market. If we were to go the old-fashioned way, which would be maybe making a mold and casting our product, we would not have been in the water by now. We would still be making it. So 3D metal printing really gives you that advantage, both time and cost. The PowerCone's deployment in a tidal environment is the first known use of 3D metal printing in the world. So we're very happy to be pioneers in this aspect.
This complex international project involving Biome Renewables, NSCC, Queen's University and Renishaw Canada really shows the power of collaboration.